In this video, we will show you how to get started with the PIC32CK SG Curiosity Ultra development board using MPLAB Code Configurator, also known as MCC. Clone the MPLAB Harmony v3 repositories and install the software shown here. You can use MCC Content Manager to clone these Harmony packages. If you are new to MCC, be sure to watch these videos. You can find the links in the video's description. For this demonstration, we will use the PIC32CK SG Curiosity Ultra development board. This project uses the ARM Cortex M33 based PIC32CK SG MCU with TrustZone support. This MCU has an integrated hardware security module HSM. For more information, watch the PIC32CK SG Curiosity Ultra development board video or visit the kit page. Here, we also use a micro USB cable and an IO1 Xplained Pro Extension Kit to test the extended functionality to read and print the current room temperature periodically. Our goal in this video is to demonstrate how a TrustZone based application is developed on PIC32CK SG Curiosity Ultra development board. The demo toggles an LED on a timeout basis and prints the LED toggling rate on the serial terminal. Also, the demo has extended functionality to read and print the current room temperature using the IO1 Xplained Pro Extension Kit. To achieve this, first, we will show you the application development overview, set up the hardware, download the project from the kit page, open the project and launch the MCC, check the peripheral configurations in the MCC, review the application code, and then compile the project and see the output. Let us now look at how a TrustZone based application is developed. A TrustZone application has two projects pertaining to secure and non-secure modes of PIC32CK SG that work together on the same MCU and offers a security isolation between the trusted and the non-trusted resources in the device. The application can be developed in two ways. First is the single developer, that is, in this case, the single developer develops both secure and non-secure application. In dual developer, secure and non-secure application are developed by two developers. Refer to the following tech brief for more details on the dual developer application development use case. This application demonstrates the TrustZone feature on the PIC32CK SG MCU. This application includes basic and extended functionality. Let's see how the basic application is implemented. The secure mode application toggles LED 0 when the switch SW0 is pressed on a timeout basis, and the periodicity of the timeout will change from 500 milliseconds to 1 second, 2 seconds, 4 seconds, and back to 500 milliseconds every time you press the switch SW0 on the board. The non-secure application requests the secure mode application to read the LED toggling rate and prints it on the serial terminal. The LED toggling rate data is transferred to the non-secure mode application when it requests through the secure application through the non-secure callables. Now, let's see how the extended functionality is implemented. The secure mode application reads the current room temperature from the temperature sensor on the IO1 Xplained Pro Extension Kit every 500 milliseconds. Further, the application writes the temperature readings to the EEPROME and reads when a request is received from the non-secure application mode. Also, LED 0 is toggled every time the temperature display request is received from the non-secure mode application. The periodicity of the temperature reading can be changed to 1 second, 2 seconds, 4 seconds, and back to 500 milliseconds whenever the user presses the switch SW0 on the board. The temperature readings are transferred to the non-secure mode application when it requests to secure application through the non-secure callables. The non-secure mode application requests the secure mode, the temperature values, and prints them on the serial console once it receives from the secure mode application. Further, when it gets a request from the user in the form of a key press on the serial console, it will request the secure mode application to retrieve the last 5 stored temperature values in the EEPROM. The non-secure application prints the last 5 stored values on the console. Also, LED 1 is toggled every time the temperature values are read from the EEPROM. Let's set up the hardware as shown to test the basic and extended functionality. To get started developing applications on the PIC32CK SG, open the web page for this evaluation kit and download the zip file for the Getting Started demo project. First, extract the demo project and open the project in MPLAB IDE. Set the downloaded project as the main project. Go to Tools, Embedded and open MCC, which will open the project graph. Here, you can see the various peripherals that has been configured for the PIC32CK SG MCU in secure and non-secure project. Click on the Plugins drop-down menu and select ARM TrustZone for ARM v8M to check the TrustZone configuration. Click on the Memory Configurations to check the secure and non-secure memory configuration of the flash, data flash and SRAM. Here, the green color indicates secure and orange for the non-secure configuration. Click on Peripheral Configurations to know which peripherals are configured as secure and non-secure. Here, you can notice that Circom5 and DMAX0 are configured as non-secure peripherals and rest are default secure peripherals. Also, notice the mixed secure peripheral and system resource configuration. Now, go back to the project graph and click on a peripheral block to see how the peripheral has been configured. For example, if you click on Circom5, you will see that it has been configured as an USART to print the LED toggling rate. If you want to configure other system-specific peripherals, use the drop-down menu under Plugins and choose the system module you would like to configure. For example, to configure the clock, open the Clock Easy View window by clicking on the clock configuration. Here, you will see that the main clock is set to the default clock frequency of 120 MHz. Select the pin configuration option. In the pin settings tab, you can see that the pin functions have been configured for various peripherals. You can use MCC to add another peripheral, reconfigure the project and generate the code. You can use MCC Content Manager to clone or download the Harmony packages or to upgrade the existing packages anytime. You can go to the project configuration path anytime and check the various files to understand how the project is implemented. The basic application demonstrates an LED toggle on a timeout basis and prints the LED toggling rate on the serial terminal. This code uses the UART to periodically send the strings. The periodic timeout can be changed by pressing switch SW0. The extended application prints the current room temperature periodically using the IO1 Xplained Pro Extension Kit. Under the project properties in MPLAB IDE, select the target kit in the connected hardware tool dropdown. Then click OK. Open a terminal application on your PC such as TerraTerm and set up the serial port. You can now use MPLAB IDE to build your project and program the evaluation kit. Here, you can see the LED's toggling rate periodically displayed on the console. The periodicity of the timeout will change from 500 milliseconds to 1 second, 2 seconds, 4 seconds and back to 500 milliseconds every time you press the switch SW0 on the board. To test the extended functionality, plug the IO1 Xplained Pro extension into the ext1 extension header and press switch 1. Navigate to the link shown on the screen for more application demos on the PIC32CK SG Curiosity Ultra development board or other development boards or kits through the MPLAB Discover. Please visit microchip.com/harmony to learn more about MPLAB Harmony v3 features, benefits, and other information. We hope you enjoyed this brief demonstration. Thanks for watching.